So in this video, I'm going to look at the convergence of a couple of recursively defined sequences. So we just want to determine if the following converge. So recursive sequences, so you have to state what the first term is, and then each successive term depends on the previous term. So notice this is a sub n minus 1 equals a sub n plus 6. So this is referring to the previous term. Okay, so the question here, though, is not like, what are the next terms? It's, do these converge? So let's talk about how would you determine the limits. So typically, what I would want to do is I would want to be able to analyze what happens as n goes to infinity in this case. Okay, so as n goes to infinity, this is going to give us some limit. And at the moment, I don't know what that limit's going to be. Now, one thing I want to state, as we get to an infinite amount of terms, it doesn't matter at some point if I have the n plus first term or the nth term. These kind of become like a negligible difference as n goes to infinity. So I'm bringing that up because at some point I know that this is going to end up converging to some limit L. At least I think it is. And so if this converges to L, if this whole thing converges to L, then we can probably also assume that these previous sequences, right, since they're all determined by this formula on some level, these would also at some point converge to L. So there's kind of like this, like, I don't know, almost like meta sequence defined on top of a sequence. So the limit is the limit type of ordeal. I don't know, it kind of messes with my head that you can do this, but right. So at like some point, since n is going to infinity, this converges to L. And so these are all recursively defined as well. These are all determined off of this formula. So at some point, all of this just converges to L. So I can set up this little situation here where I just replace everything with L's. And now I really have just like an algebra problem. So let's clear some space. All right. So first, I'm going to get rid of the denominator. So I'm going to multiply the L plus 2 to the other side. So now I've got L plus 6 equals L squared plus 2L. And then I can subtract everything to one side to get L squared plus L minus 6 equals 0. So that factors into L plus 3, L minus 2. So I have that L has to either be negative 3 or L has to equal 2. So I have two potential values, I guess, for what L could be. So the thing is, I can tell now from kind of just using my noggin and thinking about this. So if I plug negative 1 into this formula, this ends up becoming something positive. And then from there on, this is always going to be positive. So you have to kind of do a little bit of reasoning at this point to think of like what makes sense. And in this case, it's, can my limit even be negative? Could this limit go to something negative? It can't, just from the nature of this, because I'm going to plug the negative 1 in, and then everything else I'm going to plug in is just going to end up staying positive. So I can conclude then that the limit equals 2. And so since the limit equals 2, that means that the sequence itself converges. Okay, so let's use that same idea again. So, all right, I have this recursively defined sequence. So I'm going to do the same thing where I want to take the limit as n goes to infinity of this 12 minus the square root of a to the n. And I'm going to say that this equals some limit L. Okay, so if this whole thing converges to L, that also means then this a sub n will also at some point converge to L because everything is recursively defined. So there kind of comes a point where this will just end up becoming the square root of L. Okay, and so here's now what I need to go through and solve. Now, the easiest way to handle this problem would be, actually I'll drop the parentheses. So the easiest way to handle this problem is to actually isolate the square root. So I'm going to rewrite this as 12 minus L equals the square root of L. So I brought this over to one side and I brought the L over to the other side. And so now what I can do is I can square both sides. Now on the left side, I'm going to have to FOIL this. So this is going to be 144 minus 24L plus L squared equals L. Okay, and then I can subtract off the L. So this is really just something quadratic. So at this point, let me clear a little space. And I'll subtract off the L. So now this becomes minus 25L plus L squared. Okay, so this will factor into L, oops, give myself a little more space than that. This will factor into L minus 9 and L minus 16. So I have L either equals 9 or L equals 16. So once again, now I have to kind of think about like what actually makes sense here. So we just want to think about, is one of these not possible? And so the one that I think of immediately is 16, because this is 12 minus this root. So 12 minus the square root of 3 is going to be less than 16. And when I take the square root of this, right, it's always going to be 12 minus this. So this limit is never even going to approach 16. So I can feel pretty confident to throw it out. But yeah, maybe it'll eventually get to 9. We'll think maybe it does. So that will be the limit in this case. And since there is a limit, we can say that this converges. Okay, and so that's all I've got for that one. So I will leave it at that, and I will catch you guys in the next video. Thanks for watching.